Alright, so probability, we are talking about event over sample space. So here we are going to talk about probability 1. We just discussed probability 2 in our next video. So here, the word probability, we are saying, assuming A is an event. So probability of A can be greater or equal to 0, but less or equal to what? 1. Where is 0? It means probability of no event. So probability that there is no event, nothing happened or nothing occurred is 0. And probability that all the events occurred is what? 1. That is total event. Total event. It means if we add all the probabilities, we will get 1. So the term probability is like a fraction over 1. Yes. So that is all about probability. So we are going to talk about the first one is just tossing a coin. Tossing a you have a die and a coin, so we are going to just talk about a coin. You see, a coin has just two sides. We have a head and a tail. So if we toss a coin, the first one is just one time. We have only two probability. It can be a head or it can be a tail. Now if we toss a coin for two times, so we can have what? A head and a tail. They get it. You can get the first one being all head, you can get the second being a head and a tail, you can get a tail and you get a head and you get a tail and what? A tail. Right? So let me just give you a clue about how to solve all these questions. They ask you a coin is tossed, let's say 2 times. So you just draw your table like this. The first is a head, the second is a tail. The first is head, the second is what? A tail. Right? So here, head meeting head is head and head. Right? The first is head, and this side you have a tail, right? Tail. The second is what? A tail here, tail. Then this is head, right? Then here is a tail, right? The tail, then you write the head. Sorry, tail. So we have head, tail, as it is here. Tail, head, and what? That is tail, head, and what? Tail. So tail. So if they ask you, you can either write it from this side or you can just construct a table and list the element. So here, if you use these two as just represent the probability, you are seeing, okay, what's the probability of getting a head? So you just go and count the number of head. This time around we have head here, so we have head as 1, we have head and head. So here it's only this one that is not having what? A head. So probability of getting a head is what? I think probability is event over the sample space. So what is the event? Probability of getting head 1, 2, and 3. This is, we are having 3 head in there. And which one is the total space? The sample, sum or the event. The event 1, 2, 3, 4. So the total outcome is what? 4. So this probability, just the question you've been asked to what? The sample space, summing all of them. Sure. Now let's take practical examples that will just explain so many things for us. Alright, so we are going to take this question is saying a fair coin is tossed twice, write down the set of all outcomes, then good. So let's have a fair coin is tossed twice, so we have to just list all this. So a fair coin is tossed twice, so we are just listing out. So we have head, as I told you, head, tail, head, and tail. So here, these are the events, right? The event, and the total outcome is what? 4. So the first question is saying, after listing the event, what is the probability of obtaining? Yes, so I probability of obtaining exactly two heads. Exactly two heads. B, no head, at least one head. No head, at least one head. One head. Yes, and a head and a tail. D, a head, and a tail. So we are done. I told you, forget, you can just write a head and a tail, right? Let's get your head. You get your head here. You get your tail here, right? So this is just going to be your outcome, just 4. Right. So here, head, tail, tail, tail. So 4, and I've just listed them there. So you can decide to take this side or this side. Each and everyone is correct. So here, probability of having exactly 2 heads. So look into it. Which one is having exactly 2 heads? Which one is having head on all the 2 events? So you see, it's only one. It's only one. So here, where we have exactly 2 heads. So here, just one. It's having 2 heads. So exactly 2 heads is what? 1. And what is the total outcome? 1, 2, 3, 4. So 1/4. Probability of having exactly 2 heads is this. Now, probability of having no head. No head. It means on the 2 toes, there was nothing like head in it. So there was no head. So no head. So which one is not having any head? This, we have head here. We have head. So it's only this one that is not having any head. So probability of having no head, that is, so we have just the tail. So here, that's the tail. It is not having any head. You can say that is also 1/4. Then the next question is at least one head. And the word at least means it can be that number or what? More. So when you say at least what? 1. At least 1. It means if the variable is x, we are saying x is what? Greater or equal to 1. That's the meaning of at least 1. So it can be 1, s can be 1, s can be 2, and beyond. So at least 1 means it can be 1. So here we can have 1 head or what? 1 tail, right? So go and look for the one that we are having 1 head. So which one is having only 1 head? So here, this question is split into 2. We have 1 head plus 2 heads. That's the meaning of at least 1. So 1 head, which one is having just 1 head? See, for 1 head, you are having it here. You have only 1 head. And this one, you have only 1 head. So here, 1 head and 1 head. So you are having 2. So at least 1 head is 2/4, which can be simplified as 1/2. 2 cancel here, 1 and 2 go here, 1/2, right? So that is at least 1 head. Alright, 2 head. Which one is just having 2 head? We saw that the 2 head is 1, exactly 2. They have 2 heads. So you have 1/4. So yeah, the question is having at least 1 head. It can be either 1 head or what more. So this is having just 1 head. This is having 1 head. This is having 2. So we have 1, 2, 3. So that's what. You can just go straight at least and write 3/4. For this having a head, and a head. This having 1, this having 2, so 3. Or you can also split it like this. So this is 2/4. The word or in maths means plus. And this is 1/4. So you can see 2 plus 1 is what? 3 and what? 1/4. So this is 3/4. That's the meaning of at least 1 head. It can be 1 head or it can be what? 2, right? Then the next one is a head and a tail. A head and a tail. Which one is having a head and and it's having a tail. So here we have this one, it is having a head and a tail. This was having a head and a tail. You get it? So it doesn't matter the one that is leading. They are saying the head and the tail. So whether the tail is leading or the head, it's just that we are having it. So we have a head and a tail, a head and a tail. But the rest is head, is tail. So you see, a head and a tail is what? Is 2/4. And this can be simplified as 1/2. So that is that. So this is just an introduction to all that we are about to do, right? So that is the basics of probability. Sure. Now let's move on. This time around, you can see a fair coin is tossed 3 times. That is thrice. Or the question can see a fair coin is tossed 3 times, or 3 coins are tossed simultaneously, or they are tossed at the same time. So here, the first one we did was 2. Here it's 3. You just have to write your head and write your tail, right? Sure. Then here you write the outcome for 2. We know that if it is 2, we have head, we have head, tail, head, and what? Tail. Depend on how you do it. You can decide to write head and tail and make them 4 here. So it depends on you. So this one, you see, they are tossed 3 times. Here, this is 2. This is one is tossed twice. You remember, this is for 2. We toss it just 2 times. But here we are tossing it. Here is 1, so 2 and 1 making that 3. Sure. So here we have head and head, right? Here we have 2 head. Write the 2 head here. Let me just give a line. Yes, write the 2 head here. Then you go and write what is the tail. Right? We have head and tail. So write your head and your tail. Then you go and write what is here. Head. Write your head and your tail. Then you go and write what is the tail. Write your tail and your head. Then you go and write your head. Write your tail and your head. Then you go and write your tail. Write your tail. You go and write your head. Then your tail, and your tail. So here you count. This time, let's count. 1, 2, 3, 4, 5, 6, 7, 8. So you can even put a line in it. You can put a line in it. You can put a line. But don't forget, these ones are not part. It starts with here, these 2 blocks. So it's 8. Now your total sample space, we are saying the number of S is what? 8. Now let's look at this question. What is the probability of obtaining? Let me just all right, I'm just looking at some question. Like, what is the probability of obtaining exactly 1 head? Yeah, the question is here, obtaining exactly 1 head. Now the first question is exactly 1 head. Exactly 1 head. Alright, so let's look at this question. Exactly 1 head. So exactly 1 head. Please, I'm fine. It's online. I'm just Mommy is here. Mommy. I think she's sleeping. Okay. So exactly 1 head. So just go and look into which one is just having 1 head. So exactly 1 head. So here, this is our event. 3 heads, we have 2 heads. So look at where we have only 1 head. So here, we have 1 head here. Which side? Here we have 1 head for this. Which one again? We have 1 head. Can you see that? So you look at it. Which one is having only 1 head? And you'll be able to know we have only 3. So we can even list them. Head, tail, they are just 3. So write 3 over what? The total event is what? 8. So that is 3 over 8. 3 over 8. Now let's look at the second one. See, it's probability. A fair coin is tossed 3 times. What is the probability of obtaining no head? Sorry, no tail. So no tail. No tail. So look at them. Which one is not having any tail at all? No tail. No tail. All of them are having tail except the one that is having all head. Where is it? So this is having all head. And after this one, all of them are having a tail. So tail, 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 tail. So you see, having no tail, no tail. It means if you want the one that is having no tail, it means the one that is having all being head, and that is 1. So the probability is 1 over what? 8. I told you, probability is always event to a sample space, right? So right, probability of, this is how you answer the question. Probability of no tail equal probability of tails. You get the probability of no tail, that is probability of all head. You can write probability of the event. So probability that no tail over probability of total outcome. Then you write probability of no tail as 1 and over 8 as you are doing it like it. The next one, probability of at least 2 tails. At least 2 tails. So go and look at where we have either 2 tails or what more. At least it means it can be 2 or more. So look at where we have 2 tails or more than 2. So here it is 3, so 2. So here there's 1. Where we have 2, so this is also 2. This one. So let me just put asterisks there. When you finish, you just count them. So we have 2 or more. So this is also 2. This is 2. This one is having 2. That's all. So here 1, 2, 3, and 4. Right? So probability of at least 2. No, the question is 2 tails. Sorry, it's not 2 heads. The one I'm doing is 2 heads. So assuming it's just 2 heads, let's make this one 2 heads. When you finish, you come and do 2 tails. So 2 heads. 2 heads. In that one, you're going to have, we had all being head. We had head, head, tail. We had head, tail, and head. We have 2. Yeah. Oh, no, wait, no, okay. 1, 2, 3, 4. So we have 4. It's 4 over what? 8. And 4 over 8 is just 1 over or 2. 4 will divide here by 1. Now let's go to all tails, like at least 2 tails. The same thing. At least 2 tails. It means we can get either 2 tails or what? More tails. That is 3. So this, we are having 3 tails here. So let's go and see where we have the tails being 2. Here our tail is 2. Where else? Here our tails is 2. We have, so we see we also have 1, 2, 3, 4. So the same thing, right? So at least. So this one too, at least probability of having at least 2 tails is also what's going to be 4 over what? 8, which is 1 over 2. So it's the same thing. Just that make sure when we say probability, like 3 coins are tossed at the same time. 3 coins are tossed. It's 3. So the first one side here is just 2 coins. When you toss 2 coins, and here 1 coin, making 3. So this is where you do it. So 3 coins. This is how we do it. So we have 3, first, second, and third. Now let's add a quick question. Let me just add one quick question. So the last question is like, what is the probability of obtaining a head in the middle of the 3 tops? So see, probability of obtaining head in the middle. So look at something. We have 3. 1, 2, 3. 1, 2, 3. You can see all of them are 3. So having a head at the middle. So check the middle one. Which one is having head? Then you count them. So if they are 5, you just count them. So look at something. Let me clean my asterisks and my damn marks and that. So here, which one is having head at the middle? You have number 1 head, number 2 head, number 3 is having head, is having head. That's all. So you see we have 1, 2, 3 and 4. So we have 1 having head at the middle. We have all being head still at the middle. You see this one. You can see 2 head, and what? 2 head, 2. 1, 2, 3, 4. So this is also the same as 4 over what? 8, which is 1 over 2. Exactly. So we are done. What's coins? So we are just going to toss a die. Alright, in this probability, I'm saying a die is tossed at once. So if you throw a die, you know that for a die, these are just the ones, just 1, 2, 6. When you see a non-biased die, it means all the sides are shown. So 1 to 6. So probability of having what? An even number. So check the even numbers out. So 1, you just write your even numbers from this. So how many even numbers? You have 2, 4, 6. So even numbers you have 3, right? So the event is 3. So the probability is 6. So the probability of having an even number equal 3 over 6, which is 1 over 2. 3 go here, 1 go here, 2. Having a perfect square, you know a perfect score. So here, the number that when you find the root, you not get any remainder. So here, for perfect square, just take this one, 1. You have 1, and you have what? 4. These are the only perfect square we have. For square root of 1 is 1. Square root of 4 is what? 2. Find square root of all the other number with the exception of this. You are going to get your remainder. So we have perfect squares. Our perfect square, we have 1 and 4 and doing the only numbers there. So probability of having this perfect square, we are going to get 1 and 4, which is 2. So 2 over 6, which is 1 on 3. Having a prime number, you know probability of having a prime number. Probability of prime, no prime numbers. They have only 2 factors when you divide them by what? They just have only 2 factors. Prime numbers have 2 factors. So here, which of them have only 2 factors? We have 1. This has only 1 factor. You get it? So this out. You select what? 2. Factors of 2. You have 1 and 2. You have 3 and what? 5. So the prime numbers here, you have 2, 3, and then 5. So we are having only 3. So it's 3 on what? 6, because all the events 1, 2, 3, 4, 5, 6, which is 1 over 2. So the same thing. So when you say a mark more than 4, any mark more than 4 is what? 5 and 6, and you're going to get 1, 2. So 2 are what? 6. So they can just ask you anything like that. Now let's take a question that we are just going to toss 2 coins at the same time. So let's say we have 2 coins, A and B. It can be 2 coins, A and B. You can say a coin is tossed 2 times. So you know we have for coin that we are tossing it 2 times, as we did it for a die. So you write 1 on top and 1 at the other side, then we just compare. So we have 1, 2, 3, 4, 5, 6. This is the first one. Tossing the coin, the die for the first time. Then the second 1, 2, 3, 4, 5, 6. So then you compare, right? So let me just just give some lines here. Some lines. Alright, so here it's manageable. So here 1 and 1, you have 1 and 2. You are just comparing. So here if you write 1 from this side, you write 1 on top. So here 2, 1, so all are started. So 2 will start. Then you just add what is there, 2, 3, 4, 5, and 6. So 3, 1, 3, 2, 3, 3, 3 and 4, 3 and 5, 3 and 6, 4 and 1, 4 and 2, 4 and 3, 4 and 4, 4 and 5, 4 and 6, 5 and 1, 5 and 2, 5 and 3, 5, 4, 5, 5 and 5, 6. I'm just going to just get something done here. 6, 5 and 6, 6. Sure. We're done. So that is that. Now let's tackle our questions. Alright, so with this question, it is construct a table showing all the equally likely outcomes. So the table is here. The next one is from your table, find the probability that the sum of the numbers on the dice is 5. So to find the probability that the sum on the die on the 2 dice is, so let's take the first one, 5. So the sum on the die is 5. If you sum them, you get 5. So here, let me just teach you a simple method to just do it. Look at the first one. Which one among them that when you add them you get 5? Just identify one. 1 and 4. 1 plus 4, you get what? 5. 1 and 4, you are going to get 5. So if you add 1 and 4, this one will give you 5. Sure. Then you just run a line, just a straight line. So 1 and 4, you are getting 5. 2 and 3, you get 5. 3 and 2, you get 5. And 4 and 1. That's all. You see, we are done. So we have 1 and 4. If you sum them, we get 5. We have 1 and 4. We have 2 and 3. We have 3 and 2 and what? 4 and 1. You can see just a line. You are good to go. So you count them 1, 2, 3, 4. So 4 and what? 36. That is the total outcome. Because how many boxes are we having? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 times 6 is 36. See, you can also count them to check, but it's 36. 4 and 36. Now the second is find the probability that the sum on the 2 dice is what? 10. So as I showed you, sum like 2, that will give you just 10. If you get it from the top, then you just strike a line through, then you get it. So sum them. Which one is going to give you 10? A is going to give you 8. So which one is going to give you 10? You see, 5 plus 5 will give you what? 10. Good. So you see here, 5 plus 5 is 10. Can you see this line? So you can see the sum is 10. So if you sum the 2 dice, it's 10. Baby. So you see, you have 4 and 6 will give you 10. 5 and 5 will give you 10. And what? 6 and 4 will give you 10. So we have 3. So this is a 3 on what? 36. 3 over 36. Now, the next question says that find the probability that the 2 dice show the same score. So let's see that they show the what? the two dice show the same score. Check. So we are finding the probability that they have the same score. So we just go and with this one, there is two, there is three. Just run a line as I just taught you. So the one that is having the same die on the two, you have 1 and 1, you have 2 and 2, 3 and 3, 4 and 4, you have 5 and 5, and you have 6 and 6. So they are what? Just 6. So you write 6 over 36. And you know 6 over 36, if you reduce, you get 1 over 6. 6 will divide itself. 1 divide 36 by what? 6. So here. So what if this time around the question says probably that the two dice show different scores, because at first it was just the same, so different what? Scores. If it shows different scores, it means if the first one is 1, the second is not 1, so it is different. So you see all the die, we have 36 outcome. So if 6 is showing the same score, so in the isolate it's just 30 over 36. This one is showing what? That's 5 or 6, showing different score, because 1 over 6 is showing the same score. So it's just like 1 minus those that are showing what? The same score. So that is also what? Simple. Now the next one, find the probability that the sum of the two dice is more than 5. Sorry, more than 6. So that the sum on the two dice